So in this section, we will be using the digital out factor to flash the red LED. This is a more generic way of doing things, and you can use this code to turn on and off any digital output, not just the red LED. So let's get started. We'll go to Setup, and again, we uncheck or delete the ones that we don't want. So we're going to take away the red LED, and let's find the digital out. And it's down here, digital 1 on. So let's see what it needs in terms of answers from us. Which pin is it going to be? Well, we're going to duplicate the red LED, so that'll be 13. Let's say OK here. The name, well, we got to give it a name. Last time I used it, I called it red LED, so let's keep going with that. And number of seconds. Now, this is the total time that the demo is going to run each time it runs. So let's make it a shorter number, not 60 seconds. Let's make it a 10-second one. Now, remember last time it was number of flashes that was controlling. This time it's number of seconds, and you'll see how the code is slightly different because of that. So we say 10 seconds, and then within that period, as it's going on and off, what's the on and off period going to be? Let's say it'll be 500 milliseconds on and 300 milliseconds off. All right, so that's enough, and let's make the code. All right, getting there. Just relax. Okay, so that's it. Let's look at the code now. Just want to see if it caught the last area in the code. Okay, so it's red LED, but you see it says stroke stroke V? That's because it replaced it with the name that we set for the output, and we put it right in there. And for the hardware, it's again the stroke stroke V. It put that name right in there. So the digital out 1 is 13, where we set it. See how similar it looks to the other way of doing it up till now. And pin mode, it's pin digital out 1 instead of pin red LED, and it's an output. And let's see, the comment was updated too. Loop is the same. We're still going to run the demo out of a function called run demo. But let's see how this is different now. So now we're using this end time variable, and this is sort of like an alarm clock, and the end time is what we set it to be, and it's going to run until that time is up. So milliseconds, that's the current time in thousands of seconds, plus 10 times 1,000. We said 10 seconds, so this code multiplies the 10 by 1,000 to make it 10 seconds, and adds it onto the current time in milliseconds, and that becomes when things should be finished. So here it says while milliseconds is less than the end time. So this is going to loop around for 10 seconds. And again, it's going to turn the digital out I, and then hold on to it for 500 milliseconds, and then it's going to turn it off and hold on to the timing for 300 milliseconds. And then it's going to go back up again to here. So it's going to run for at least 10 seconds. Now, if these delays had been set to be 5 seconds and 3 seconds, something like that, it would start the last one within the 10 seconds, but the whole time might be 13 or 14 seconds, something like that, because it extends beyond the final time point. So that's the code. You'll see how it was quickly generated, and it's similar but different to the red LED code. I'm not going to send it off to the Arduino at this point to see if it runs. You can have pretty good confidence that it will run.